Yeah, I can do 8. 2 plus or minus root 6, and then going through a point 3 comma root 6. Okay. So, what do we need for our equation? We need A, B, and the center. Actually, none of these three things we currently have, but since the foci are directly opposite the center, I know the center will be in between them, or otherwise the center will be at 2 comma 0. So let me draw a quick sketch. 2 root 6, 2 negative root 6, so it is vertically oriented. The center is in between. We have some kind of ellipse around these guys. Just gonna do my best here. And we have a point 3 comma root 6. I'll do it here in cyan. This doesn't tell us a whole lot at this point, besides the fact that it satisfies our equation. So you can actually, so if you use the equation, if you have x squared, so wait, what's our equation? X minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. Let me plug my h and k because I know the center. So x minus 2 squared divided by a squared, don't know it, that's actually what I'm looking for, plus y minus k. K is 0, so I just do y squared divided by b squared equals 1. I could plug these 3 comma negative 6 into here for x and y, and I would get an equation of a and b. And then since I actually know c, a squared plus b squared plus c squared, sorry, a squared equals b squared plus c squared. So, let's see. You would get one equation and two equations. Two equations of two variables, and it would be a system of equations. I do not recommend this, right? So you could plug this in for x and y, and then you have two equations of a and b. It's not worth your time. I'm going to show you the easy way, or even the more intuitive way. So this is going to save you time. So, what you notice, Mr. Sullivan is blowing my email up. So, at this covertex, the distance from the covertex to the focus, we know by our little anatomy diagram, is a. So both of these legs sum to 2a. On the other hand, I don't know what each of these legs are, but they better sum to 2a. Otherwise, it's not a proper ellipse, right? The definition of an ellipse is predicated on this relationship that the sum of these legs is always the same for any point on the ellipse. So what I'm going to do is I'm going to find the distance between these 2 points, and I'm going to find the distance between these 2 points, and then set it equal to 2a, and then I will get the value for a. So I want to find the distance between those 2 points, which is this point and one focus. This is problem 6. So the distance between this point and one focus, let me actually copy this so I can bring it down. Whoops, that's fine. So the distance equals the square root of the difference in x coordinates, 3 minus 2 squared, plus the difference in y coordinates, root 6 minus root 6 squared. That's one of the distances we need. And the other distance we need is to the other focus, 2 comma negative root 6. So the distance would be 3 minus 2 quantity squared, difference in x coordinates, plus root 6 minus negative root 6, or plus root 6 quantity squared. So I need to sum these two distances. So here I get square root, isn't that 1 plus 2 root 6 squared? 2 root 6 squared will be 24. So root 1 plus 24, we get 5 for this distance. And here we get 3 minus 2 squared is root 1 plus 0 squared, root 1 is 1. So d2 equals 1. So going back to this leg is 1 unit, and this leg is 5 units. So 2a equals 6 units. So a equals 3 units. Since we found a, b is very easy to find. Any questions about this? Did that answer your question, Henry? Very rude problem. Uh, 6 and 7. Do you need them both, or can I just get away with doing one of them? If you need them both, it's fine. Oh wait, you said 7 and 8. Oh, you don't need 7? Are you sure? What's your question on 7? I'll go ahead and do 8 though. If you have a question on 7, please do let me know. I thought Isabella had asked for 2 questions. So here we have number 8 is 3x squared plus 4y squared minus 18x plus 24y plus 3 equals 0. I need to get this in standard form of an ellipse. Yeah, I'll help you with the foci for sure. So we need to get the x's together, 3x squared minus 18x. We need to get the y's together, plus 4y squared plus 24y. I'll go ahead and move the 3 over. I want to factor out of the x's before I complete the square. You don't have to, but I would really recommend this. Otherwise it's going to be really difficult. Same story for the y's. Y squared plus 6y equals negative 3. I'm going to complete the square now. So this would be plus 9, and I just created 27 units. So I want to add 27 units. And this would be also plus 9. So I just created 36 units. So I need to add 36 units on the other side to balance it out. So here on the left I get 3 lots of x minus 3 squared plus 4 lots of y plus 3 squared equals 24 plus 36 is 60. Divide everything by 60. So you get 3/60ths. Shouldn't 5 be y minus 2 and x plus 3? I'll take a look here in a second. It probably is. So mistakes are made. So 20 x minus 3 squared over 20 plus y minus 3 squared, y plus 3 squared, divide by 15 equals 1. Is this good, Isabella? Do you have a question about that? 5. Yeah, it should be x plus 3, y minus 2. Yeah, number 5, y'all, it should be x plus 3 and y minus 2. So just switch the plus 3 and the minus 2 on number 5. So how do you get the foci here? So a squared is 20. B squared is 15. And the center is at 3, negative 3. Actually, Henry, this will answer your question. So take a look. Once you have a squared and b squared, you can get c squared. So c squared is 5. So c is root 5. C will be root 5 units away from the center along the major axis. So what's the major axis? Well, the major axis has to be horizontal because x has the bigger number. So if the major axis is horizontal, the foci will be root 5 units away. So this will be 3 plus root 5 for the x value and 3 minus root 5 for the x value, and the y value remains the same. Does this answer y'all's question? Does this make sense? The foci always lie on the major axis, the longer one. Is that good, you two? Do you have a question now that you've seen that? Cool. Any other questions? All right. Do you feel pretty confident with this worksheet now? Is it like not too bad? Besides 6? I'm gonna assume that's a yes if you don't say anything. Okay, so let's talk about eccentricity. I'm not talking about the personality trait. Eccentricity. By the way, some of y'all were a little late, so make sure to be on time, please. I'm still gonna be lenient. But you should be on time for your own sake, rather than to avoid tardies. So, we're talking about eccentricity. What is eccentricity? I'm going to give a really loose definition here. Don't tell my college professors. So, how elliptical is it? Or how stretched? So a circle is an ellipse with eccentricity equals 0. It's literally a circle. It hasn't been stretched. It is a circle. It's an ellipse, but it's a circle, right? As it becomes more elliptical, it will stretch out more and more. So if E equals 0.9, and then when E equals 1, we'll talk about that eventually, but not today. Do you have any questions about eccentricity? So I will assume y'all are pretty comfortable with that. And the way to calculate eccentricity, very simple formula, it's just the proportion between C and A. Right? C is the focal length, right? And A is the major axis, right? What's the focal length of the circle? Well, the center is both foci, so C is actually 0. So E equals 0 over A. That's why the eccentricity of a circle is 0. So I'm going to give you an ellipse, and I would like you to find the eccentricity. So let's see. Let's say x squared over 40 plus y squared over 50 equals 1. Go ahead and find the eccentricity, please. And round to 3 decimals. Another way to think about eccentricity is how far are the foci away? So when the eccentricity is very large, so E is always less than 1 and greater than 0, greater than or equal to 0. This is a constraint on E. The closer and closer E gets to 1, the farther and farther these foci get out. So actually, when E is 1, the distance between the foci is infinite, which is actually really strange to think about, but we will talk about what that means. Okay, so most of you should be done with this by now. So a squared equals 50, b squared equals 40, so c squared is 10, so c is root 10, so e equals c over a root 10 over root 50, so I get, whoops, square root 10 over 50, or 1/5, 0.447. Is that what y'all got? That seems actually kind of large. That's what you got? Cool. I guess that makes sense. So that is eccentricity, and I'm going to show you something that I think is very interesting. So let's go to Desmos here. Okay, y'all can't see that, can you? It's just a blank screen. Can you let me know if you see a blank screen? Yeah, okay. Let me close Desmos really quick. Not Desmos, but Discord. Sometimes it gets really temperamental. I'm back. Alright, so what are we looking at? This is planetary orbits. When planets orbit the sun, or whatever star we're talking about, or any kind of gravitational orbit, it's an ellipse. And the center of mass of the system is one of the foci of said ellipse. So I've just got some planet rotating around the sun with certain A values and B values, and my eccentricity is actually constantly being calculated right here. So really the focus would be the center of mass between the sun and the planet, but the sun is just such a large mass as compared to the planet that we can say the sun basically is the focus. It's more like the focus would be just a little off towards the planet. But this is a well enough approximation. And so as I change A and B, it will stretch, and watch this eccentricity value change. So less eccentric means closer to a circle, more eccentric it starts looking very stretched. So most planets are about eccentricity 0.3. And actually most of our planets are even less eccentric. They're almost completely circular. Something like, let's see, 4.14. Yeah, something like that. So it is an ellipse, but you can hardly tell, right? And so I'll also send you guys a link to this so you can play with it. So the planet's going to go around and around with the sun at the focus. And we have two more bits of information here, and this isn't about math, but this is about a problem we're about to do. There are two astronomical measures called the perihelion and the aphelion. This is Latin, so this is closest to the sun, perihelion. That's the distance from when the planet is closest to the sun. And the aphelion is the distance from when the planet is farthest from the sun. They both range along the major axis. And as the eccentricity changes, their relative distances change. If the eccentricity is 0, let's see, what happened here? As the eccentricity is 0, the foci are in the center, and the perihelion and the aphelion are the same. I mean, that makes sense. It's a circular orbit, right? And as this changes, the perihelion will get smaller, and the aphelion will get larger and larger. Any questions about any of these words or planetary orbits or anything like that? it's not just planetary orbits, any gravitational orbit. Comets in our solar system come in and out, and comets have extremely long eccentricity. They'll be gone for a long time and then come close. Any debris that's orbiting the Earth will be, the Earth would just be its center of mass. So it would be experiencing gravity to the sun, but really the gravity in that system that it really cares about is the Earth, because it's so close. And the moon orbits around the Earth in an ellipse as well. So any orbital motion at all is elliptical. And so that's one reason ellipses are really cool. So let's try a problem here. Let me pull this problem up. Alright, so given some values, we're talking about Mercury right now. We're going to find the equation of Mercury's orbit if the ellipse were centered at the origin, and we're also going to find its eccentricity. So all we need are the perihelion and the aphelion. So let's see. Perihelion is 28.5 million miles. We're just going to keep it in millions of miles so we don't have to deal with a trillion zeros. Aphelion, let's see. The aphelion is 43 million miles. Also, one more bit of information that we could use is the diameter of the sun, which is 870,000 miles. Well, what's the first problem? We need these all in millions of miles. So really what we're talking about is 0.87, isn't it? We want to use that number. And we'll see why we need that here in a minute. So let's draw a picture. I'm going to draw Mercury's orbit here in green. Some elliptical orbit, and Mercury is orbiting all around this ellipse. Right, everywhere on this ellipse Mercury will be, and the sun is here at one of the foci. We are given the perihelion, which is 28.5 million miles. And the aphelion, which is 43 million miles. And we can't consider the sun as a point. It has its own width of 0.87 million miles. So, if we want to find the equation, we're going to need A and B. We already have the center. That's no problem. Any clue how we can find A or B? Any ideas? I'll let you guys think about it for a moment. If you have an idea, let me know. We're just gonna say the center is 0. 0, 0. Yeah. So centered at the origin. Can you hear me, the water? So when that animation was happening with the planet going around the sun, my cat was swiping and biting at the planet on my screen. It was very adorable. Does nobody have an idea how to find A or B? We do not know A. If you think you know A, what is A? 28.5. A is not 28.5. So I'll actually help you with a picture here. So, yes, what Capel just said. So A is the distance from the center to the end, or half the distance of the entire major axis. So Dylan, that's basically correct, but you are currently considering the sun as no width. We have to count that width in. So we remember that A is half of the major axis. Major axis divided by 2, and we have the major axis here. It's the sum of these three numbers. So if I sum these three numbers and divide by 2, I'll get the major axis. So A, well, if I sum them, I get the major axis. If I divide by 2, I get A. So A is 28.5 plus 0.87 plus 43, all divide by 2, and I get 36.185. So we have that. How do we get B? Or C? If we know C, we can get B. Any ideas, y'all? Minus 28.5. You're both wrong. But you're both almost right. The B is the length from the focus to the center. It's the focal length. So, the focus, well, I would say you're both right because I didn't even clarify. The focus is at the center of the sun. So we have to consider half of this length. So the focal length C, so I'll say you both got it right, so don't worry. It's kind of my fault for not clarifying. So we get A is the entire length from the center to the end. If I take A and subtract 28.5 and subtract half of 0.87, I should get C. So A minus 28.5 minus 0.87 divided by 2 equals C. So using A that we already found is 36.185, I get that C is 7.25. Now that we have C, B should be no problem at all, right? We can just use our Pythagorean formula. A squared equals B squared plus C squared. So I'll do that quickly. So we get 36.185 minus C squared, 7.25, and these are both squared. This equals B squared. So I can just take the square root of this. And so B, I get, we're just going to round to 3 decimal places here usually. B is 35.451. Why would I be worried if I got a B larger than A? Because A has to be the largest. So that's one thing you can, yeah, you bet. subtract C from A? No, we had C. We were using C to find B. So in this Pythagorean theorem, we have A, we have C, we're looking for B. Does that answer your question? Cool, wonderful. So we have A, B, and C. We also, we have everything we need. Let's go ahead and write the equation and find the eccentricity. B is 35.451. We found that with the Pythagorean theorem after we knew A and C. So this is A squared and C squared. What do you mean minus 7? So if I want to isolate for B squared, I have to subtract C squared to the left side. So that's why I have minus C squared. Yeah. If this were plus, that would make B the largest value of the three as well. A has to be the largest value of the three. Very cool. Okay, so we get x squared over a squared because it is horizontally oriented. It didn't have to be, but that's the way we drew it. Plus y squared over b squared equals 1. So I get, let's take a look, x squared over 1309.354. Three decimals is good enough for me. Plus, thankfully this isn't science class, we don't have to worry about sig figs or margin of error or anything like that. 1256.791 equals 1. So here is our equation. And we can calculate A knowing, we can calculate eccentricity knowing A and C. So eccentricity equals C over A. And that is 7.25 divided by, yeah, 1 second, Hugh. I'll answer that question. 36.185. And the eccentricity is, I didn't calculate it earlier. 7.25 divided by 36.185 is 0.20 ish. 0.20, yeah, that's fine. 0.200. So, how did I get 35.451? So it's the square root. It's this squared minus this squared, and then square root. Would you like to see me do it like one step at a time? I can. Cool, wonderful. So let me check the actual eccentricity of we're talking about Mercury, right? Mercury eccentricity is 0.21. So it's actually 0.21. We were pretty close. We made some assumptions, right? And the assumption is that the main assumption is that the sun is the center of mass of the system, which it basically is, but we have other things to worry about. And also, as the planet goes around, it's going to get closer and closer to other large bodies that will make it deviate from the orbit ever so little. But, I mean, on an astronomical scale like this, an assumption like that is completely fine. So, that's what I wanted to show you today. And for your homework, I would like you to do this exact same thing, but with Mars. So please find the equation for Mars's orbit and its eccentricity. You will have to find, well, you don't have to find, but I would like you to find the perihelion and aphelion online. Wikipedia is fine. Just use some source, right? So just Google this, no problem. and then go through this same process. Using the perihelion and aphelion, you can find A, B, C, and then calculate the eccentricity and write down the equation. So this is the homework, just one problem. And then once you do find the eccentricity, compare this with the known value. And see how close you were. Any questions about the homework? And you know what? Nah, never mind. This sounds good. Thank you so much. Enjoy finding the equation for Mars. I know some of you are disinterested in this kind of thing, and some of you are interested in this kind of thing. So either way, I just wanted to show y'all some planetary stuff. And with that, y'all are dismissed, and have a wonderful day.